Welcome to Loops and Loops, your premier destination for all things Raspberry Pi. In the world of single-board computers and DIY projects, the Raspberry Pi stands as a beacon of innovation, offering endless possibilities for learning, tinkering, and creating. Join us as we embark on an exciting journey through the realm of Raspberry Pi, exploring its diverse applications, uncovering its powerful capabilities, and empowering you to turn your ideas into reality. Whether you're a seasoned maker, a tech enthusiast, or a curious learner, get ready for an enlightening experience. So tighten your loops and let's dive into the fascinating world of possibilities together. Raspberry Pi is like a tiny but mighty computer that fits in the palm of your hand. Imagine it as a versatile Swiss Army knife for tech enthusiasts and DIY enthusiasts alike. It's not just a computer. It's a whole ecosystem of possibilities waiting to be explored. At its core, Raspberry Pi is a single-board computer, meaning all its essential components like the processor, memory, and input-output ports are packed onto a single circuit board. This compact design makes it perfect for projects where space is limited, like building your own smart home gadgets or tinkering with robotics. Unlike traditional desktop computers, which often come pre-assembled and are designed for general-purpose computing tasks, Raspberry Pi is more like a blank canvas. You get to decide what you want to do with it and tailor it to suit your specific needs. Whether you're into coding, gaming, or crafting, Raspberry Pi can adapt to your interests. Speaking of components, Raspberry Pi board typically includes a CPU, which is Central Processing Unit, RAM, which is Random Access Memory, storage options like micro SD cards, USB ports for connecting peripherals, HDMI ports for video output, and GPIO pins for interfacing with external devices. The CPU is like the brain of the Raspberry Pi. It's responsible for executing instructions, running programs, and processing data. Despite its small size, the CPU in Raspberry Pi packs quite a punch, capable of handling a variety of tasks with ease. Raspberry Pi can run different operating systems, including popular choices like Raspbian, which is based on Debian Ubuntu, and even specialized ones like RetroPie for retro gaming enthusiasts. This flexibility means you can choose the operating system that best suits your project requirements and personal preferences. When it comes to programming, Raspberry Pi supports a wide range of languages, making it accessible to both beginners and experienced developers. Python and Scratch are particularly popular choices due to their simplicity and versatility. Whether you're writing code to control LEDs or building a web server, Raspberry Pi has you covered. Setting up a Raspberry Pi is like assembling a puzzle. You start by downloading the operating system onto a micro SD card, then plug it into the Raspberry Pi board. Connect a keyboard, mouse, and monitor, and you're ready to dive into the world of Raspberry Pi. Now, let's talk about some common uses for Raspberry Pi. From creating your own media center with Kodi to setting up a home automation system with Home Assistant, the possibilities are endless. You can even turn it into a retro gaming console, or use it as a platform for learning electronics and programming. One of the coolest things about Raspberry Pi is its ability to support DIY projects and prototypes. Whether you're building a weather station, a remote-controlled robot, or a smart mirror, Raspberry Pi provides the perfect platform to bring your ideas to life. When connecting peripherals to a Raspberry Pi, you have a variety of options at your disposal. From USB keyboards and mics to HDMI displays and audio speakers, you can easily expand its capabilities to suit your needs. General-purpose input-output GPIO pins is like the Swiss Army knife of Raspberry Pi. It allows you to connect external devices like sensors, LEDs, and motors directly to the Raspberry Pi board, opening up a world of possibilities for experimentation and customization. Digital and analog input-output operations. Raspberry Pi let you interact with the physical world. Whether you're reading sensor data, controlling LEDs, or measuring voltages, Raspberry Pi gives you the tools you need to bring your projects to life. hats or hardware attached on top are like expansion packs for Raspberry Pi. They're add-on boards that extend its functionality by providing additional features like sensors, displays, or wireless connectivity. Whether you're building a weather station or a home automation system, there's a hat for that. Raspberry Pi is perfect for building smart devices that can connect to the internet and communicate with each other. Whether you're creating a weather station, a home security system, or a smart thermostat, Raspberry Pi has the power and flexibility you need to bring your IoT ideas to life. Connecting sensors and actuators to Raspberry Pi is as easy as plugging them into the GPIO pins on the board. These pins allow Raspberry Pi to interact with the physical world by reading sensor data and controlling external devices like LEDs, motors, and relays. In the world of home automation, Raspberry Pi is like the brains behind the operation. It can control lights, appliances, and other smart devices in your home, turning it into a fully automated and connected space. Whether you want to set up voice-controlled lighting, automated blinds, or a smart doorbell, Raspberry Pi can make it happen. When it comes to networking and communication, Raspberry Pi is like a networking wizard. It can connect to Wi-Fi networks, Ethernet, Bluetooth, and even cellular networks, allowing it to communicate with other devices and services both locally and over the internet. SSH, or Secure Shell, is like a secret tunnel that allows you to remotely access and control your Raspberry Pi from anywhere in the world. With SSH, you can log into your Raspberry Pi's command line interface and run commands, transfer files, and even access graphical applications. Raspberry Pi can run a variety of networked applications and services, from web servers and file servers to media servers and home automation platforms. Whether you're hosting a website, sharing files with friends, or streaming movies to your TV, Raspberry Pi has you covered. Setting up Kodi or Plex on Raspberry Pi is like turning it into a full-fledged media center. Kodi lets you organize and stream your media collection, while Plex lets you access your media library from anywhere in the world. With Raspberry Pi, you can enjoy your favorite movies, TV shows, and music on any screen in your home. Raspberry Pi is like a time machine that can transport you back to the golden age of gaming. With emulators like RetroPie, you can play classic games from consoles like the NES, SNES, and Sega Genesis right on your Raspberry Pi, whether you're reliving childhood memories or discovering retro gems for the first time. Raspberry Pi makes retro gaming easy and fun. Multimedia playback and streaming on Raspberry Pi are like a breeze. Whether you're watching movies, listening to music, or streaming content from the internet, Raspberry Pi can handle it all, with support for popular media formats and streaming services. Raspberry Pi is the perfect entertainment hub for your home. GPIO pins allow you to connect external hardware, like sensors, LEDs, and motors directly to the Raspberry Pi board, opening up a world of possibilities for DIY electronics projects. Whether you're building a robot, a weather station, or an arcade cabinet, GPIO pins are your best friend. DIY electronics projects using Raspberry Pi are like a playground for creativity and innovation. Whether you're building a robot, a home automation system, or a weather station, Raspberry Pi provides the perfect platform to bring your ideas to life. With its powerful hardware and flexible software, the sky's the limit for what you can create. Raspberry Pi is like the ultimate tool for building robots. Whether you're building a simple robot car or a sophisticated humanoid, Raspberry Pi provides the brains and brawn you need to bring your robotic creations to life. With its GPIO pins and support for motors and servos, Raspberry Pi makes controlling robots easy and fun. In educational settings and STEM programs, Raspberry Pi is like a teacher's dream come true. It's an affordable and accessible platform that makes learning electronics and programming fun and engaging for students of all ages. Whether you're teaching kids to code, building robots, or exploring the wonders of the universe, Raspberry Pi has something for everyone. Raspberry Pi is like a friendly teacher for anyone looking to learn programming and electronics. With its affordable price tag and user-friendly interface, Raspberry Pi makes it easy for beginners to dive into the world of coding and circuitry. Whether you're a student, a hobbyist, or just curious about technology, Raspberry Pi has something to offer. Physical computing with Raspberry Pi is like bringing your projects to life. It's all about connecting the digital world of software with the physical world of hardware. With Raspberry Pi, you can create interactive gadgets, robots, and sensors that respond to the world around them. It's a hands-on way to learn about electronics and programming that's both fun and educational. For beginners, Raspberry Pi offers a treasure trove of simple and fun projects to get started with. From building a basic LED blinker to creating a weather station or a retro gaming console, there's something for everyone. These projects introduce key concepts like coding, circuitry, and problem solving in a way that's accessible and engaging. When it comes to real-time data acquisition and processing, Raspberry Pi is like a wizard. It can collect data from sensors and other devices in real time, process it on the fly, and take action based on the results. Whether you're monitoring temperature, humidity, or motion, Raspberry Pi has the power and flexibility you need to handle it all. Interfacing sensors with Raspberry Pi is like connecting the dots between the digital and physical worlds. Whether you're using temperature sensors, motion detectors, or cameras, Raspberry Pi makes it easy to gather data from the world around you. With a few lines of code, you can start collecting data and turning it into useful insights. Raspberry Pi plays a crucial role in environmental monitoring and data logging. Whether you're tracking air quality, soil moisture, or water levels, Raspberry Pi can collect and store data over time, allowing you to analyze trends and make informed decisions. It's like having a mini weather station or environmental monitoring system right at your fingertips. Data visualization and analysis with Raspberry Pi are like painting a picture of your data. Whether you're plotting temperature trends, analyzing rainfall patterns, or visualizing sensor data in real time, Raspberry Pi has the tools you need to bring your data to life. With libraries like Matplotlib and Plotly, you can create stunning visualizations that make complex data easy to understand. Data logging and visualization. With Raspberry Pi are like building a bridge between the physical and digital worlds. It's all about collecting data from sensors, storing it in a database or file, and then visualizing it in a way that's easy to understand. Whether you're monitoring the weather, tracking energy usage, or analyzing sensor data, Raspberry Pi has the tools you need to make sense of your data. For weather enthusiasts and amateur meteorologists, Raspberry Pi is like a dream come true. With its ability to collect data from sensors like temperature, humidity, and barometric pressure, Raspberry Pi can create custom weather stations that rival those used by the pros. Whether you're tracking storms, predicting rainfall, or monitoring wind speed, Raspberry Pi has you covered. Setting up a camera module with Raspberry Pi is like adding eyes to your project. Whether you're building a security camera, a wildlife monitor, or a home surveillance system, Raspberry Pi can turn any project into a powerful imaging device. With its camera module and easy-to-use software, Raspberry Pi makes it easy to capture, process, and analyze images in real time. Raspberry Pi plays a crucial role in image capture, processing, and analysis. Whether you're capturing photos, recording videos, or analyzing images for objects or patterns, Raspberry Pi has the tools you need to get the job done. With its powerful hardware and flexible software, Raspberry Pi is go-to tool for image-related projects. Computer vision and object recognition with Raspberry Pi are like giving your project a superpower. Whether you're building a security system that can detect intruders, a robot that can navigate its surroundings, or a camera that can recognize faces, Raspberry Pi can turn your ideas into reality. With its support for libraries like OpenCV and TensorFlow, Raspberry Pi makes it easy to implement advanced computer vision algorithms. Machine learning with Raspberry Pi is like adding a brain to your project. Whether you're building a smart home assistant, a predictive maintenance system, or a self-driving car, Raspberry Pi can help you train machine learning models and deploy them in the real world. With its powerful hardware and flexible software, Raspberry Pi is like a playground for AI enthusiasts and researchers. Whether you're building a robot that can recognize objects, a chatbot that can answer questions, or a recommendation system that can suggest products, Raspberry Pi has the tools you need to bring your AI ideas to life. With its support for libraries like TensorFlow Lite and PyTorch, Raspberry Pi makes it easy to run machine learning models on the edge, right where the data is collected. Raspberry Pi manages data like a digital librarian, organizing and storing information in various ways to meet different needs. With its flexible storage options, Raspberry Pi can handle everything from simple file storage to complex databases. Setting up external storage with Raspberry Pi is like adding extra shelves to your library. Whether you're using a USB flash drive, an external hard drive, or a network-attached storage device, Raspberry Pi can connect to it and access its contents with ease. Raspberry Pi plays a crucial role in network-attached storage solutions, acting as a central hub for storing and sharing files across a local network. With software like Samba or Nextcloud, Raspberry Pi can turn any external storage device into a powerful NAS system, allowing users to access their files from anywhere, anytime. When it comes to web servers and hosting, Raspberry Pi is like a miniature data center. With software like Apache or Nginx, Raspberry Pi can serve web pages, host web applications, and even run content management systems like WordPress or Joomla. It's like having your own personal web hosting platform right home. Setting up Nginx on Raspberry Pi is like building your own web server from scratch. Whether you're hosting a simple blog, an e-commerce site, or a multimedia gallery, Raspberry Pi can handle it all with ease. With a few configuration tweaks, you can customize your web server to meet your specific needs. Web applications and services running on Raspberry Pi are like tiny islands in the vast ocean of the internet. Whether you're hosting a personal blog, a photo sharing site, or a collaborative wiki, Raspberry Pi can provide the infrastructure you need to make it happen. With its low cost and energy efficiency, Raspberry Pi is the perfect platform for hosting small-scale web projects. Security and privacy are top priorities for Raspberry Pi users, and the platform offers several tools and techniques to help protect against threats and vulnerabilities, from basic security practices like keeping software up to date and using strong passwords to more advanced measures like firewall configuration and intrusion detection. Raspberry Pi provides the tools you need to keep your data safe and secure. Securing a Raspberry Pi board and its applications is like locking the doors and windows of your house. Whether you're protecting against malware, hackers, or other threats, Raspberry Pi offers a range of security features to help keep your data safe. By following best practices and staying vigilant, you can minimize the risk of unauthorized access and data breaches. Raspberry Pi plays an important role in cybersecurity education and training, providing a hands-on platform for learning about security concepts and practices. Whether you're studying for a certification exam or just exploring the world of cybersecurity, Raspberry Pi offers a safe and affordable way to experiment with different tools and techniques. Raspberry Pi supports the development of projects involving AI and deep learning, providing a powerful platform for training and deploying machine learning models. With libraries like TensorFlow and PyTorch, Raspberry Pi can run complex neural networks and perform tasks like image recognition, natural language processing, and more. TensorFlow and other AI frameworks on Raspberry Pi are like supercharged engines for your projects, allowing you to unlock the full potential of machine learning on a small, low-cost device. Whether you're building a smart home assistant, a computer vision system, or a voice-controlled robot, Raspberry Pi has the tools you need to make it happen. Examples of Raspberry Pi projects involving neural networks and AI-like glimpses into the future of technology. Whether you're building a self-driving car, a medical diagnostic tool, or a personalized recommendation system, Raspberry Pi can help you bring your AI ideas to life. With its low cost and accessibility, Raspberry Pi is the perfect platform for experimenting with cutting-edge AI technologies. Raspberry Pi handles real-time audio processing and synthesis like a virtuoso musician, turning raw audio data into beautiful sounds in real time. Whether you're building a digital synthesizer, a music player, or a voice-controlled assistant, Raspberry Pi can handle it all with ease. Setting up audio input and output on Raspberry Pi is like tuning your instrument before a performance. Whether you're using a USB microphone, a USB sound card, or the built-in audio ports, Raspberry Pi can capture and play back audio with high fidelity and low latency. Raspberry Pi plays a crucial role in music production and digital audio workstation DAWs, providing a flexible platform for recording, editing, and mixing audio tracks. Whether you're composing a symphony, remixing a song, or producing a podcast, Raspberry Pi has the tools you need to bring your musical ideas to life. Raspberry Pi lends a helping hand to projects involving MIDI controllers and synthesizers, acting as the brain behind these musical devices. By interfacing with MIDI instruments and synthesizer modules, Raspberry Pi can generate and manipulate musical signals, allowing users to create their own custom sounds and effects. Physical computing with Raspberry Pi involves using sensors and actuators to interact with the physical world. Raspberry Pi can connect to a variety of sensors, such as temperature sensors, motion detectors, and light sensors, and respond to changes in the environment by controlling lights, motors, and other devices. Raspberry Pi projects involving sound and music are like mini concerts in the comfort of your own home. Whether you're building a digital piano, a drum machine, or a DJ controller, Raspberry Pi can handle it all with ease. With its powerful audio capabilities and extensive library of music software, Raspberry Pi is the perfect platform for exploring the world of sound and music. Raspberry Pi handles network and internet connectivity like a seasoned navigator, keeping you connected to the digital world no matter where you are. With built-in Wi-Fi and Ethernet ports, Raspberry Pi can connect to the internet and communicate with other devices on your network, allowing you to stream media, browse the web, and access cloud services with ease. Setting up Wi-Fi and Ethernet connections on Raspberry Pi is like plugging in a power cord, simple and straightforward. Whether you're connecting to a wireless network or a wired Ethernet connection, Raspberry Pi can detect and configure the necessary settings automatically, making it easy to get online in no time. Raspberry Pi plays a key role in IoT Internet of Things projects, serving as the central hub for collecting and analysing data from connected sensors and devices. With its low cost, small size, and energy efficiency, Raspberry Pi is the perfect platform for building smart home devices, environmental monitoring systems, and more. Raspberry Pi supports the development of home automation systems by providing a flexible platform for controlling smart devices and appliances. Controlling smart devices with Raspberry Pi is like conducting an orchestra, with each device playing its part in creating a harmonious environment. Whether you're turning on lights with a voice command, adjusting the temperature with a smartphone app, or monitoring security cameras from a web browser, Raspberry Pi can orchestrate it all with ease. Raspberry Pi projects involving home security and monitoring are like having a digital watchdog watching over your home. Whether you're building a motion-activated camera system, a doorbell with facial recognition, or a smart alarm system, Raspberry Pi can help you keep your home safe and secure. Raspberry Pi handles remote access and administration like a digital butler, allowing you to control your device from anywhere in the world. With tools like secure shell and virtual network computing, you can access your Raspberry Pi remotely, run commands, and even view the desktop interface from any computer or mobile device. Accessing Raspberry Pi remotely using secure shell and virtual network computing is like having a magic portal to your device, allowing you to interact with it as if you were sitting right in front of it. Whether you're troubleshooting a problem, installing software updates, or just checking in on your device, remote access makes it easy to manage your Raspberry Pi from anywhere. Raspberry Pi plays a crucial role in cloud computing and distributed systems, providing a low-cost, energy-efficient platform for building cloud-connected applications. With its small size and low power consumption, Raspberry Pi can be deployed in large numbers to create distributed computing clusters, edge computing nodes, and more. Raspberry Pi supports the development of cloud-connected applications by providing tools and libraries for interacting with cloud services and APIs. Whether you're building a web application, a mobile app, or an IoT device, Raspberry Pi can connect to cloud platforms like AWS, Google Cloud, and Microsoft, allowing you to store data, run algorithms, and access services in the cloud. Cloud storage and synchronization with Raspberry Pi are like having a virtual filing cabinet in the sky, allowing you to access your files from anywhere, anytime. Whether you're backing up your data, sharing files with friends, or syncing documents between devices, cloud storage makes it easy to keep your files safe and accessible. Examples of Raspberry Pi projects involving cloud services and APIs are like glimpses into the future of technology, where devices seamlessly interact with each other and the world around them. Whether you're building a smart home system, a weather monitoring station, or a social media bot, Raspberry Pi can help you bring your ideas to life with the power of the cloud. In the realm of secure communication and privacy protection, Raspberry Pi acts as a reliable guardian, facilitating encrypted connections and secure data transmission. By implementing encryption protocols, Raspberry Pi enables users to communicate securely over networks, shielding their data from eavesdropping and tampering. Whether it's exchanging sensitive information or accessing remote resources, Raspberry Pi ensures that privacy is upheld and communication remains secure. Raspberry Pi supports the development of projects involving GPS and navigation, by providing the necessary tools and capabilities for interfacing with GPS modules and processing location data. Interfacing GPS modules with Raspberry Pi involves connecting the module to the GPIO pins or USB port, configuring the serial communication protocol, and passing the NMEA sentences output by the GPS module to extract location information. Examples of Raspberry Pi projects involving GPS tracking and mapping include vehicle tracking systems, wildlife monitoring devices, and navigation aids for outdoor activities. With its ability to receive GPS signals and compute accurate location coordinates, Raspberry Pi opens up a world of possibilities for location-based applications and services. Real-time location-based services on Raspberry Pi leverage GPS data to provide users with location-aware information and functionality. By integrating GPS data into web and mobile applications, Raspberry Pi enables developers to create location-based services such as mapping applications, geolocation-based advertising, and location-aware social networks. Raspberry Pi plays a significant role in citizen science and environmental monitoring initiatives, empowering individuals and communities to collect, analyse, and share environmental data. Whether it's monitoring air quality, tracking wildlife populations, or studying weather patterns. Raspberry Pi provides a versatile platform for building custom environmental monitoring systems. In projects involving satellite communication, Raspberry Pi serves as a powerful tool for tracking and communicating with satellites. By interfacing with satellite tracking hardware and software, Raspberry Pi enables users to receive satellite telemetry data, track satellite orbits, and communicate with satellites using radio frequencies. Examples of Raspberry Pi projects involving satellite imagery and data analysis include satellite ground stations, weather satellite receivers, and satellite imagery processing systems. With its computing power and versatility, Raspberry Pi enables users to capture, process, and analyze satellite imagery for various applications, including weather forecasting, environmental monitoring, and disaster response. Raspberry Pi handles satellite data reception and processing efficiently, allowing users to receive, decode, and analyze satellite signals with ease. By connecting to satellite receivers and utilizing software-defined radio technology, Raspberry Pi can receive a wide range of satellite signals, including weather satellite imagery, AES ship tracking data, and amateur radio transmissions. Setting up satellite ground stations with Raspberry Pi involves installing and configuring satellite tracking software, connecting the Raspberry Pi to a satellite receiver and antenna system, and configuring the software to receive and decode satellite signals. With its low-cost, compact size, and energy efficiency, Raspberry Pi is an ideal platform for building satellite ground stations for educational, research, and hobbyist purposes. Raspberry Pi plays a vital role in educational outreach and STEM initiatives, providing students and educators with a hands-on platform for learning about computing, electronics, and programming. By offering affordable, accessible hardware and a wealth of educational resources and tutorials, Raspberry Pi empowers learners of all ages to explore STEM subjects in a fun and engaging way. Raspberry Pi plays a significant role in supporting the teaching of programming and electronics in schools by providing an accessible and versatile platform for hands-on learning. With its low-cost, compact size and user-friendly interface, Raspberry Pi enables students to experiment with programming languages like Python and Scratch, as well as to explore concepts such as circuitry, sensors, and actuators. By engaging in hands-on projects and experiments, students can develop critical thinking skills, problem-solving abilities, and a deeper understanding of computer science and electronics concepts. Hands-on learning with Raspberry Pi involves students actively participating in building and programming projects rather than passively consuming information. This approach encourages creativity, curiosity, and experimentation, allowing students to explore their interests and develop practical skills in a supportive and engaging environment. Whether it's programming a robot, building a weather station, or creating a digital artwork, Raspberry Pi empowers students to take ownership of their learning and pursue their interests in programming and electronics. Examples of Raspberry Pi projects for K-12 and higher education include coding workshops, robotics competitions, science fair projects, and makerspace activities. These projects span a wide range of subjects and disciplines, from computer science and engineering to physics and biology, providing students with opportunities to apply their knowledge and skills in real-world contexts. By working on collaborative projects and sharing their creations with others, students can develop teamwork, communication, and presentation skills, as well as a sense of accomplishment and pride in their work. Raspberry Pi handles multimedia content and entertainment by serving as a versatile platform for media playback, streaming, and emulation. Setting up media centers and streaming services on Raspberry Pi involves installing and configuring software such as Kodi or Plex, connecting the Raspberry Pi to a TV or monitor, and accessing media libraries stored on local storage or network drives. With its support for various multimedia formats and codecs, Raspberry Pi can serve as a cost-effective alternative to traditional media players and streaming devices. Raspberry Pi supports the development of media players and home theaters by providing hardware and software solutions for multimedia playback and streaming. With its HDMI output, audio capabilities, and support for popular media player software, Raspberry Pi can serve as the heart of a home theatre system, delivering high-quality audio and video content to a TV or projector. Whether it's streaming movies and TV shows, listening to music, or playing games, Raspberry Pi offers a flexible and affordable solution for home entertainment. Internet radio and podcasting with Raspberry Pi involve setting up software such as Icecast or Shoutcast for streaming audio content over the internet, as well as installing podcasting software like Podcast Generator or PodPi for creating and publishing podcasts. By connecting a microphone or audio input device to Raspberry Pi and configuring the software settings, users can broadcast live audio streams or record and publish podcast episodes with ease. With its support for audio playback and streaming, Raspberry Pi offers a convenient platform for creating and sharing audio content online. Examples of Raspberry Pi projects involving digital media and entertainment include building custom media players, creating interactive installations, and developing multimedia art projects. Whether it's designing an interactive music player, building a digital jukebox, or creating a multimedia art installation, Raspberry Pi provides a flexible and customizable platform for exploring the intersection of technology, art, and creativity. Raspberry Pi handles power management and energy efficiency by implementing various hardware and software optimizations to reduce power consumption and prolong battery life. Optimizing power consumption in Raspberry Pi projects involves selecting energy-efficient components, optimizing software code for efficiency, and implementing power-saving features such as sleep modes and dynamic voltage scaling. By minimizing power usage and maximizing efficiency, Raspberry Pi can operate reliably in battery-powered and energy-constrained environments. Raspberry Pi plays a crucial role in renewable energy systems and sustainability by providing a platform for monitoring, controlling, and optimizing energy usage. With its support for sensors, actuators, and communication interfaces, it can collect data on energy consumption, generation, and efficiency, as well as control devices such as solar panels, wind turbines, and batteries. By analyzing energy data and implementing intelligent control algorithms, Raspberry Pi enables users to maximize the use of renewable energy sources, minimize energy waste, and reduce their carbon footprint. Solar-powered Raspberry Pi projects involve integrating solar panels, charge controllers, and batteries with Raspberry Pi to create self-sustaining systems that operate off-grid or in remote locations. By harnessing solar energy to power Raspberry Pi, users can build solar-powered weather stations, environmental monitoring systems, remote surveillance cameras, and more. With its low power requirements and efficient operation, Raspberry Pi is well suited for solar-powered applications, providing a versatile platform for sustainable and environmentally friendly projects. Raspberry Pi handles real-time data acquisition and analysis by interfacing with sensors and actuators to collect data from the physical world and process it in real time. This process involves connecting sensors, such as temperature sensors, humidity sensors, and motion sensors, to the GPIO pins of the Raspberry Pi board. By reading sensor data and controlling actuators, such as motors, lights, and relays, Raspberry Pi can interact with its environment and respond to changes in real time. Raspberry Pi plays a crucial role in data logging and environmental monitoring by continuously collecting and recording data from sensors over time. This data logging process involves storing sensor readings in a database or log file, which can then be analysed and visualised to gain insights into environmental conditions and trends, with its support for various sensors and communication interface. Raspberry Pi can monitor parameters such as temperature, humidity, air quality, and more, making it suitable for a wide range of environmental monitoring applications. In projects involving air quality monitoring, Raspberry Pi collects data from sensors that measure parameters such as particulate matter, carbon dioxide, carbon monoxide, and volatile organic compounds. By analysing air quality data in real time, Raspberry Pi can detect pollution events, monitor indoor air quality, and provide alerts or notifications when air quality levels exceed safe thresholds. This capability makes Raspberry Pi a valuable tool for monitoring and improving air quality in homes, offices, schools, and other indoor environments. Data visualization and analysis, with Raspberry Pi involve using software tools and libraries to process and visualize sensor data in meaningful ways. This can include plotting sensor readings on graphs, generating charts and histograms, and creating interactive dashboards for monitoring and analysis. By visualizing sensor data, users can identify patterns, trends, and anomalies, enabling them to make informed decisions and take appropriate actions based on the data collected by Raspberry Pi. Examples of Raspberry Pi projects for weather stations and climate monitoring include building DIY weather stations, tracking atmospheric conditions, and collecting weather data for research or educational purposes. These projects typically involve connecting sensors such as temperature sensors, humidity sensors, barometric pressure sensors, and wind speed sensors to Raspberry Pi, then logging and analysing the data to monitor weather patterns and trends over time. Raspberry Pi handles data transmission and communication by supporting various communication interfaces such as Wi-Fi, Bluetooth, Ethernet, and USB. This allows Raspberry Pi to communicate with other devices' sensors and networks, enabling it to send and receive data over local networks or the internet. By setting up wireless communication with Raspberry Pi, users can remotely control and monitor their projects, access data from anywhere, and integrate Raspberry Pi into IoT ecosystems and connected environments. In IoT projects and smart devices, Raspberry Pi serves as a central hub or controller that connects and coordinates various sensors, actuators, and devices in a networked environment. By interfacing with sensors to collect data and controlling actuators to perform actions, Raspberry Pi can automate processes, monitor conditions, and enable smart functionality in homes, offices, and other environments. This makes Raspberry Pi an ideal platform for building DIY automation systems, smart home devices, and IoT prototypes. Controlling devices and appliances with Raspberry Pi involves connecting them to the GPIO pins or other interfaces of the Raspberry Pi board, then using software to send commands or signals to control their operation. This can include turning lights on and off, adjusting thermostat settings, opening and closing doors, and more. By integrating Raspberry Pi with sensors and actuators, users can create custom automation solutions tailored to their specific needs and preferences. Examples of Raspberry Pi projects for smart homes and DIY automation include building home security systems, controlling lighting and heating, ventilation, and air conditioning systems, monitoring energy usage, and managing home entertainment systems. These projects leverage Raspberry Pi's capabilities to automate tasks, monitor conditions, and provide remote control and monitoring capabilities for various aspects of the home environment. Integration with cloud platforms and services allows Raspberry Pi to access additional resources, storage, and functionality available in the cloud. This can include connecting Raspberry Pi to cloud storage service, such as Google Drive or Dropbox, to store and synchronize data, as well as accessing cloud-based application programming interfaces for services such as weather data, mapping and geolocation, and machine learning. By leveraging cloud services, Raspberry Pi can extend its capabilities and interact with a wide range of online services and applications. Raspberry Pi plays a central role in IoT ecosystems and connected environments by serving as a flexible and customizable platform for building and integrating IoT devices, sensors, and applications. By connecting Raspberry Pi to sensors, actuators, and networks, users can create intelligent systems that collect data, analyze information, and take action based on real-time conditions. This enables Raspberry Pi to be used in a wide range of IoT applications, from smart homes and cities to industrial automation and environmental monitoring, contributing to the development of connected and intelligent environments. Raspberry Pi offers an excellent platform for exploring robotics due to its affordability, versatility, and ease of use. With Raspberry Pi, you can build robots ranging from simple wheeled vehicles to complex humanoid robots. The Raspberry Pi board serves as the brain of the robot, controlling motors, sensors, and other hardware components. To get started with robotics on Raspberry Pi, you'll need a basic understanding of electronics, programming, and mechanical assembly. Beginners can begin by building a simple wheeled robot using a chassis kit, motors, wheels, and a motor controller. Raspberry Pi can then be mounted on the chassis and connected to the motor controller to drive the robot's movement. Python is the preferred programming language for robotics on Raspberry Pi due to its simplicity and readability. You can use Python libraries to interface with hardware components and control robot behavior. Additionally, libraries like OpenCV and TensorFlow enable advanced image processing and machine learning capabilities for robotics applications. Raspberry Pi's camera module provides a powerful tool for robotics vision systems. You can use the camera to capture images or video streams, which can then be processed for tasks such as object detection, recognition, tracking, and gesture recognition. Machine learning techniques can be employed to train models for these vision-based tasks. Beyond wheeled robots, Raspberry Pi can also be used to control robotic manipulators and arms. These robots are equipped with joints and actuators that enable them to grasp, lift, and manipulate objects. With Raspberry Pi as the control unit, you can program these manipulators to perform tasks such as pick-and-place operations, assembly, and manipulation objects. Raspberry Pi robotics enthusiasts often participate in competitions and challenges to showcase their skills and creativity. These events range from local robotics clubs and meetups to international competitions like RoboCup and First Robotics Competition. Competitions provide opportunities to collaborate with other enthusiasts, learn new skills, and push the boundaries of robotics technology. The Raspberry Pi community offers a wealth of resources and support for robotics enthusiasts. Online forums, tutorials, and documentation provide guidance on building, programming, and troubleshooting robotics projects with Raspberry Pi. Additionally, open source projects and code repositories offer ready-made solutions and libraries for common robotics tasks, accelerating the development process. Create a gesture recognition system using Raspberry Pi and machine learning algorithms. With a camera module or motion sensors, you can capture hand gestures and train a model to recognize specific gestures and trigger actions such as controlling devices, playing games, or navigating interfaces. Raspberry Pi can serve as the brain of autonomous vehicles such as drones, rovers, or self-driving cars. By integrating sensors, cameras, and machine learning algorithms, you can create intelligent systems capable of navigating and interacting with their environment autonomously. As we wrap up today's exploration of Raspberry Pi, we hope you're inspired to embark on your own Raspberry Pi projects and explore the endless possibilities this versatile platform has to offer. Don't forget to subscribe to Loops and Loops for more captivating content on electronics, programming, and DIY projects. Let's continue to loop in new knowledge, innovate with technology, and push the boundaries of what's possible with Raspberry Pi. Until next time, keep those loops tight, keep experimenting, and keep creating with Raspberry Pi. Thank you for joining us on this exhilarating journey.